thanks for joining me. Let's have a look at this 3x8 step sequencer. Now there's quite a lot to cover in this video, and hopefully I'll get all the relevant information in if you bear with me. Please don't put your jacks on the right there like I did. There's a clock in, CV out and trigger out, and an external reset in as well. Each step has got its own switch. Now on many 8-step sequencers, the basic baby 8s, they're just too busy, and as far as I can make out, they're gate sequencers. And if you put a step in the off position, I found that it does actually trigger, and we need a little bit more circuitry to overcome this, and it'll just make it a trigger sequencer. So we're going to have a further look at this. Let's flip it over and have a look at its rear end. Now, if you are a complete novice and you're not sure how to wire this up, you might have to do a little bit of research. There's many layouts for the Baby 8, and here's quite a simplified one. I'm not too sure where I sourced this from. It might be Casper Electronics. Read this through half a dozen times if needs be, and if you still don't understand it, read it again another 6 times, and it might start to sink in. Having a further look, the ribbon cable there, these are sent to the reset rotary switch. Check out that diagram I showed you to get an understanding of how that works. That's a jumper wire that you can use to send to the LF398. That is in the stripboard layout that I've got. There's the bit of a mess of the power regulator, and these are the Weimer caps for each LF398 hold, the hold voltage capacitors. If you want the external reset in, please put a 1418 diode, which I've just indicated, and take that to the center switch or the center tab of the rotary switch. And whilst we get onto my layout now, I want to try and explain as to why I'm using the LM317. Now, you'd think we might just be able to run this off 9 volts, but not using transistors for LED drivers. I can't put a heavy load resistor on the LEDs. If I could explain that a bit better, standard cheap LEDs that we can buy, multi-packs, we don't know what kind of value we're getting, and I found they're way too bright, and it really is a bit of a pain seeing these bright LEDs flash. So I had to come to some compromise with the power. So 9 volts, I needed something like 47k on the LEDs, and this is really it's overboard. There really should be only something like 1k max on the LEDs. Also, the higher resistor value we put on that, that's also going to reduce the CV out. Now, I tried a 5 volt regulator, and how many chips have we got there? 1, 2, 3, 4, 5, 6, 7, 8. The 5 volt regulator there, it didn't seem to cope, and I didn't seem to be getting 5 volts out. So I've just managed to squeeze in the LM317. Now what you can do with that is adjust the 5k potentiometer there to a suitable voltage. Now, I would recommend actually getting your multimeter on the CV out, and I really wouldn't have it more than 3 volts maximum, because if you're trying to dial in a voltage, please bear in mind this isn't quantized, but if you are trying to dial in a voltage to your quantizer, any more than 3 octaves is tricky, dialing in a right note. So even 2 volts, that's 2 octaves, that's enough. So just adjust that trimmer till you get about 2 volts, 2 to 3 volts. And I just want to remark on the LEDs again. I did manage to get some that were 200 MCD, I think that's millicandela, and I'm happy with that. 400 might be okay. There's a lot of listings online for these LEDs, and it doesn't give you a spec sometimes, but see if you can get any for 200 MCD and a 1K load resistor on each of those LEDs. I'm pretty happy with that. Now, I'm trying to hold your attention, but if you can just hang around and we'll have a look at how I've configured this. So there's 3 separate 4017s for each track. Now, they can have individual clocks, although you should be able to multi those together for one clock, but it's potentially gives you a bit more scope if they're individually clocked. I've got the max 1044 there. That is to supply a negative voltage, which the LF398 requires. That's just in the spec. It does need a negative voltage. So there's an three LF398s there. That's for each track too. They're to hold the last voltage on each step. Now, there's also the 4081 there, which is a quad and gate. So we're taking the clock as one input, and then a step on trigger from each track. So when they are both high, that's the only time we're going to get a trigger out. I do hope this makes sense. Have a think about it, and have a good look at this diagram to get an idea of what's going on. If you've got any questions, then please leave them in the comments, and I'll see if I can help you. But just have a think about this. I've laid it out as logically as I can, and you might have to do some work yourself. This is DIY after all. Now, I'm trying to cover as much as I can without getting too boring. Now, I've got sequence out bus 1, 2 and 3. So that's the input from each separate bus out. Please have a think about this. I'm really having trouble explaining it, so please excuse me. And then you've got the sequence 1 out. Well, that is going to be your main trigger out point, okay? So it needs to go through this 4081 AND gate before it goes to the final output stage, and that is just for the triggers. And the LF398, that's pretty much the same architecture. You have a CV out bus going in, and then we trigger that to hold that voltage, and then that held voltage goes to the main CV out. Well, I think I'm going to have to leave it at that. This has been quite thoroughly tested. It's going to cost you about £50. There is a lot of hardware with the pots and switches. but I think anything on the market is going to cost you a couple of £100. It is pretty similar to one of the dope sequencers I've seen. Yeah, I'm going to recommend building this. And if you don't want to do the three sequencers, then hopefully you can get some tips there with the LF398 to pimp out your Baby 8. And yeah, like I say, please leave any questions. And thanks for watching, guys. I'll hopefully see you soon.